Hello everyone and welcome back to a new session. This session is to go over Chapter 12 in review. Chapter 12 is Advanced File Operations. We need to know file operations, file output formatting, file access flags, passing file stream objects to functions, and member functions for reading and writing files. We need to know working with binary files and creating records with structs or structures. Finally, we need to know about random access files. So all these topics are required for us to review. So I'm gonna write them here. File operations and flags, access flags. We need to know file output formatting. We need to know passing file objects between functions. We need to know binary files. And finally, or not finally, working with struct records. And finally is random access files. So random access files. File operations. So first thing is file operations. You need to know already, or you know already, that we have two type of files. We have the if stream and we have the off stream. So if stream and off stream, this is for input file stream, stands for input file stream. This stands for output file stream. So input file stream, this data type can be used only to read data from file into my program. So input from the file into my program. Off stream, this data type is to be used to create files and to write data to them. So output from my program to the file. These two are what you already know. For chapter 12, which is advanced file operation, we're gonna introduce the general fstream object. Fstream object, stands for file stream eventually. This data type is general and can be used to create files, write data to the files, and read data from them. Now, when you work with fstream, you will have to specify the access mode for your file. So this brings us to file access flags. You have modes for accessing the file. Every time you create a file, you will have to provide a mode for your file. So basically, whether you're creating the fstream to read or to write or to append or to truncate, so you have different modes. The first mode is iOS : app. Next one is iOS 8, iOS binary, iOS in, iOS out, and finally iOS trunk, which is truncate. So append is to open a file and add to the end of it. Append mode, meaning I need an fstream object and I need to open that file and write to that file in an append fashion, meaning the file will have lines that already there, and I need to open that file and add to the end of it. I don't need to clear the content, I need to add to the content. 8, which is similar to append, but it differentiate append and uh, mm, it differentiate between append mode, that append can and or will open the file and point at the end. At end will open the file and point at the end, but will allow me to move up and down. In append mode, I'm not allowed to go back. So this is called at end. Now, this is maybe a little early in the chapter because it is specific to random access files, but you don't have to worry about it now. This is for binary mode. Binary mode, just like you have a lot of file extensions or file type. You have text, you have doc, you have Excel, for example, and you have binary. Binary is nice to work with just because it's fast. The fact that it's binary, meaning there is no bridge between translating text to binary for the CPU. Working with binary files makes it fast because it's easier for the CPU and faster for the CPU to execute or to read or to search or to sort. So the only disadvantage for binary is when you open the file, it's gibberish. You're not gonna be able to read what's in the file as a human. If I create a binary file and start adding data to the binary file, and then I come to the folder and I open that file, it's not gonna be in English language. It's gonna be random characters, the way that the notepad translates binary. It's not gonna be understandable, but binary files are faster to work with. In mode is to open a file for read. I need if I specify the in mode, meaning I need to open a file and I need to read from that file. In this case, writing to the file is not gonna work. On the other hand, open file for rewrite. Meaning, if I open this file with this mode and I try to to read from the file, it's not gonna work because the fstream object was specified with the out mode. Truncate means clear all in that file. So basically replacing the file, which is similar to what you know already when you create an off-stream. When you create an off-stream and the file already exists, it will clear its content and replace it with a new file. So this default behavior for off-stream is similar to truncate, which is clearing all content of the file. All content of some existing file. So in code, you might be wondering, okay, how do I do this in code? You basically say, I need an fstream, my file, for example, and then my file dot open, and then here I give it the file name, as a string, and then the mode iOS, for example, in semicolon. By specifying the mode, I'm basically specifying the functionality. So here I'm saying my file is called whatever file name, and then I want my file to be for reading from the file. If I go ahead and execute my file dot write, it will not work because this file was created in the in mode. So you need to make sure how to do main 4 tasks in any files. Whenever you're working with files, you need to know 4 steps. The first step is to open the file. The second step is to check if the file was opened successfully. The third step is to process the file, whether you are reading or writing. And the last step is to close the file. Each of these 4 steps is as important as the other. Just like you can't process a file without opening the file, so opening the file is very important. Just like we can't close the file without opening the file, it's as much important as opening the file. You can't process the file unless the file was opened successfully. So all these 4 steps are important, especially close file, because if you don't close the file, then another task or another code in your program will not be able to access the file. Imagine you have different tasks working on your file. Task 1 or code 1, code 2. Imagine I have task 1, task 2, task 3, and task 4. No matter what the responsibility is, maybe the responsibility is task 1 is to read, maybe task 2 is to write, maybe task 3 is to truncate, maybe task 4 is to whatever, search in the file. So if task 1 opens the file and then doesn't close the file, so it needs to do those 4 steps. Anytime task 1 needs to execute, it needs to do those 4 steps. If the close step is missing, then anytime task 2 gets executed, it will not be able to succeed because task 1 didn't release that file. If you ever noticed, sometimes you try to open a file in your computer and then it tells you this file can't be opened because it's being used by another process. You will get into that problem, and as you know, in C++, if one code fails, if that code is not safe or bulletproof or doesn't have any like exception handling, if that code fails, then the entire program will crash. So closing the file is very important because you don't want other tasks to crash your program. So this is for the flags. Sometimes you need to know, you need to check if the file exists before trying to open it. For example, if I'm trying to truncate, I need encode to be safe, just so truncate doesn't execute stuff or code or statements or instructions on a file that doesn't exist. So when I create my fstream, before I open this file, I should check, hey, does this file exist? And then I can open that file. There are a lot of code for uh, uh, checking if a file exists or not, um, but you need to keep that in mind. The next topic is outputting a formatting the output. So formatting the output. Just like you can format the output in the cout statement, you need to use the IO manip library. You go to your code and you say, I need to include input output manipulators. Similar, in files, whenever you need to format your output, you're gonna need to, sorry, this is manipulator. You need to go to your file and you say, I need to include input output manipulators. Oh. Input output manipulators. The same functions and the same way you use IOManip in the cout would be the same way you use IOManip with formatting output. So you basically have the set precision function, precision. You have the fixed, you have the right alignment, you have the left alignment, you have the width function. What else? 1, 2, 3, 4, 5. Let's see. I think those were it. Set width. Yeah, these are it for IOManip. Please correct me if I'm wrong, but these are it. You have set precision for the decimal display. So anytime you need to decimal display, you set precision. You say, for example, 3, then it will show 1, 2, 3 decimal places. This would be my integer. So, for example, 1000 dot 123. If I say set precision 1, then it will only show 1 decimal place. Right, left for alignment, fixed for using fixed notation, not, for example, exponential notation. Sometimes the language will do some formatting, automatic formatting for you. For example, your number would be for something like this, and then if you try to display it, the language will automatically say, oh, this is 1 times exponential minus 10, for example. So fixed, telling, when you specify fixed keyword, you're telling your program, hey, I need it to be as is. I don't want any change, default change by the code. And set width is to specify the width space on your screen. So for example, I have 1, 2, 3 integer. I can set width to be 10. Then this 1, 2, 3 will consume 10 characters on the screen. So it will display it as space, 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 5, 6, 7, 1, 2, 3. So 1, 2, 3 will take 10 characters as a width on the screen. This helps in formatting your output so that it looks nicer on the screen. So if you don't know IOManip from the cout object, you need to review that topic and you need to know how to format it with files. The same way you use it with the cout object is the same way you use it with the file object. Next topic is to review passing file stream objects to functions. In similar fashion to passing primitive data types, similar fashion to passing abstract data types, you will be passing file stream objects to functions. However, you need to keep in mind that you better pass it as a reference. Just so whoever called your function, let's say I have two functions. I have a boss function, and then I have worker function 1, worker function 2, worker function 3. When the boss function is controlling or managing the process, it will call worker 1. Worker 1 will execute its task, and then it will return that, hey, I'm done. Then boss will call worker 2, for example, call worker 3, and then maybe back to worker 2, then maybe worker 1, then maybe back to worker 2, worker 3. So the boss is interacting with those functions. It depends on the task. It calls 1 to 3 or 3 to 1 and maybe 1, 3, 2, then back to 1. So every time if a boss pass a file stream object to worker 1, the boss needs to know what did worker 1 do with the file. So imagine I have this file. Oops. And this file has a lot of lines. Then boss, for example, is gonna tell worker 1, hey, I need you to open the file and read the three strings or 3 integers. Then worker 1 will open the file, will point here, it will read the first integer, it will read the second integer, and then it will read the third integer. So now it is here. It started here and now it's here. When it returns back to the boss function, the boss needs to know where is the pointer right now. Where are we reading wise or writing wise? It doesn't matter. But where are we? Are we done with this integer? Did we read it? Did we process it? Yes, yes, yes. Worker 1 processed it. So now boss will call worker 2 and say, for example, let's say worker 2 reads another 3 integers. So worker 2, when it receives the file stream, it will know that, oh, okay, the file stream is now here, so I need to go and read the next 3 or 2 or 4 integer, depends on the task. This is the right way. Now, if I pass it, if boss passes the file stream as a value, that means, let's undo. If it passes it as if boss passes it as value, then worker 1 will receive the file stream, and its task is to read 3 integers. And then it will return to boss that, hey, I am done. Now, the fact that worker 1 received it by value, not by reference, that means boss doesn't know what did worker 1 do with the file. And from boss's point of view, the pointer is still here. So when it calls worker 2 and tells it, hey, execute your task, read the next 3 integers, worker 2 will come and open the file, and the pointer will be still here because boss didn't know what worker 1 pointing to. What did worker 1 do with the file? Since boss passed it by value, worker 1 modified that object, stream object, and returned to the boss, and boss doesn't know what were the modifications. So boss will call worker 2, sorry, and since it doesn't know about the modifications, it will think, or it will be actually the pointer still pointing at the beginning. So it will be a logical error that worker 2 is expecting or expected to read the next 3 integers, but it will basically read the same 3 integers. So this is the concept. And when it comes to code, please go over the chapter in case you have any questions and practice the code. Then in the book, they speak about the get and put member functions. Get is to get a single character, put is to put a single character. Then they go for binary files. With binary files, you are to work with a write function. You have a, so you know how before today's session, if you have a file object, the way to write is to use this operator, and for example, my string, meaning write my string to my file. In case if you need to read from the file, you're gonna say my file to, for example, my integer. You're reading one integer from the file to the integer. Now with binary files, you cannot use this. With binary files, you are going to use the write function and the read function. Write and read. Both are very similar. The parameters, this function takes inputs and this function takes inputs. The parameters for write are basically write source pointer, the next parameter is size in bytes. So this function write expects the source pointer. Where am I writing from? You're writing from, for example, a struct address, a struct pointer, or an integer pointer. And then how many bytes am I writing? So I'm writing, so this write function will write to the file. It needs the source pointer and it needs size in bytes. Where am I writing from and how many bytes am I writing from? Yes, I'm writing to the file. Where from? The source pointer and how many in bytes. And there is a special syntax for it. Please review the code. Similar fashion for the read, it requires the destination pointer, destination pointer, and size in bytes. So read will read from the file. It needs to know where am I reading to and how many bytes I'm reading from the file. So these two are to be used when working with binary files. The special syntax is basically you need quickly you need to always cast this pointer to be a character pointer. And the special syntax, for example, let's say I'm writing one integer to my file. So I'm gonna have an integer, int my integer equals to 10, for example. So when I need to write this to the file, I'm gonna say to the binary file, I'm gonna say write. Oops, let's keep it open. Then there is a special way and size in bytes. Now we all know that integers are 4 bytes. So here I'm gonna type 4. Let's make it a little wider. I'm gonna say 4 bytes. Or I can use, for example, or I can use the size of functionality here. So I can say size of my integer, which is also 4. This is better because this doesn't, some systems integer is 2 bytes. And not just that, sometimes you really don't know what's the size of your object, of your Data type. Integers are easy, primitive, but what if it's an abstract data type? What if it's a struct? I don't know what's the size of the struct, so I just execute the size of my struct. Struct sizes are the sum of the sizes in their member variables. But every time I'm writing, I'm not gonna go to my struct and start counting, oh, okay, 4 bytes plus 1 plus 8 plus plus plus. I just execute size of my struct and it will be automatic. So back to this. Here I know that it is 4 bytes. So I'm gonna need to write to the file and it needs the source address. The source address in this case, ampersand, my integer. We all agree. Let's move it. So I'm gonna put it here, my integer. This is the source address. However, this write expects a character address, pointer to character. Now, since addresses are all of the same size in the system, whether they are 1 byte or 4 bytes for integers or whatever the size, the address is always the same. For example, this address is 1000. This address is 1002. So this is 4 digits, just as a concept, and this is also 4 digits. Just like houses. All houses are, for example, 15306. This house is 15307. These addresses. Some houses are 308. Now this is 308 is actually 00308. So the idea here, or all houses addresses are 4 digits, same size, 5 digits. So similar concept is in memory addresses. No matter what the pointer is pointing to, whether it's pointing to 1 byte or a block of bytes, it's always the same address. So this write is expecting a character address, but I can trick it, I can fool it by telling it, hey, you see this address I'm passing to you? I need you to treat it as a character address. So I need to cast it. Cast to char asterisk this guy. And here I'm going to say reinterpret cast. So reinterpret cast to char pointer, and this is the address. I'm telling the program, I'm giving you an address, and I need you to treat it as character address. And I need you to write 4 bytes from that, starting from that address. So whatever address I'm giving you, I need you to write 4 bytes, 1, 2, 3, 4, from this starting address. The address I'm giving you, treat it as a character address just for the language sake of it, just for the syntax sake of it, because if I don't give it a character address, this would be a syntax error. It's going to say, hey, write is expecting a character address, but you're giving me an integer address. So I tell the language, the programming language, the syntax that, hey, treat this address the way you want, whatever, and read 4 bytes from it. Similar fashion for the read functionality. For the read functionality, let's say I have integer, my integer, and then I can tell my file to read destination address and then how many bytes. So I'm going to say reinterpret cast to character pointer. This is a angle bracket and also this, and then the address of my integer. So this is the idea in brief and the syntax in brief. If you don't really know what I'm talking about, you have to go and read the chapter. especially this topic. The last topic is to do random access files. You need to know that you can open a file and work with it in a random access fashion. Right now, you know that if I need to open, let's say I have this file. Come on. It doesn't want to do it again. Here you go. Let's say I have this file and it has lines in it. Whatever the data in those lines, it can be integers, characters, etc. Right now, you know, then when I open or when you open a file, your file object will start here. If you read one integer or one character, then your object file will become here. Then you read, and you keep reading. So it's linear kind of thing. It goes from the beginning all the way to the end. Once it reaches the end, it's done reading. So it's linear. It goes in sequence from the beginning to the end. Random access mode, random access way is basically opening the file and then pointing here, for example, reading an integer. Then once I'm done reading this integer, I can go back. I can go point here and read another integer. Then I can go here. So I don't have to go in order from the beginning all the way to the end. I can randomly access any position in this file. With that being said, you need to know special functions for this. It's the same fstream object, but different functions. The first function is seek put. I'm going to use them the same because they are very similar. You have seek p and seek g, which is get. You have so you have seek and seek put, seek get. You also have the other one, tell. Oops. Tell P and tell G. And the last thing you need to know is the references. You have some references, which are iOS big for beginning. You have iOS end for end, and then you have iOS for current. So seek put for writing and G for get for reading. If I use seek put, that means I'm trying to go somewhere in order to put a character or put data. If I execute seek get functions, meaning I'm trying to go somewhere in the file in order to read from that position. Tell put and tell get. Tell put meaning if I execute tell put, it will tell me which position it's on. If I execute tell get, it's gonna tell me which position the get pointer is on. So you wanna imagine you have two pointers, one for get and one for put. Tell put will tell me where the put pointer is right now. Tell get will tell me where the get pointer will tell me where it is now. Seek put will move the put pointer in order to put data. Seek get will move the get pointer in order to get data. Then you have references. References are beginning, which is this point exactly, the beginning of the file. End is this point exactly. Reference points. I have the beginning, I have the end, and then you have current. Current is whatever the current position that the pointer is on right now. So with that being said, the usage of these functions is, for example, let's say I have I want to put an integer, let's say. So I can say I have an integer. I can say I have an integer. My integer equals 10, for example. Then I can open my file and check if the file has been opened successfully. And then I can say seek put, and then it requires two functions, two parameters. First one is how many bytes, sorry, indexes. Let's say it's number of bytes away from this reference. So for example, I'm gonna say from big, and here I'm gonna say 10. That means, hey, put pointer, I need you to move 10 bytes away from beginning. Positions are always in bytes. So when I say 10 big, that means you see this reference point, I need you to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now that I executed this function, I am ready to say my file dot, or if it's not a binary file, my file cout my integer. If I execute these two together, then my integer will be written in this location. Right here, I'm gonna have the number 10. Even if I have data here, even if I have data here, 10 will be written on these bytes. Same fashion, right now, if I say, hey, my file dot tell put, this will return 10 because I told it to go. 10 begin. So this will return 10. Similar to this example, I can say, I'm going to use, for example, another reference. I can use my file dot seek put -15 iOS end. That means I need you to move back from the end 1 -1. So -15, move back from this reference point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, and it will point here. Right after this statement, if I say my file dot seek put 5 from current, for example, meaning whatever your current position is, I need you to move 5. So it will come here and it will move 1, 2, 3, 4, boom, and it will point here. So this is the idea behind random access. And if you don't know the code, please go ahead and practice it. And I recommend that you actually practice it just so you refresh your memory. Please let me know if you have any questions.